Welcome back. On this episode, we are actually going to be covering the cantilever steel truss. Let's go into that. So I'm going to be showing you how to actually come up with this particular model. So we will be modeling this in this particular episode. So we'll do a model that is similar to this. It may not necessarily be exactly like this, that's very similar, just to give you an insight of how to actually come about your modeling of your steel members in your ProtaSteel structure. So let's jump right into it. The first thing I'm going to do is to click on new project. So if I click on new project, I will name this cantilever steel. Now it is important for you to understand that in ProtaSteel structure you cannot space, so you will have to use any of these characters, whether you use dash or you use comma or you use underscore. Okay, so these are the available characters you can actually simply use in ProtaSteel structure to space a title. So the title of this entire project is cantilever steel, and I will click on OK. Okay, before then I will have to select the code of practice. It's more like the template I actually want to use. So I'm going to be using BS8110 for the sake of this training. So if we come down to our modeling tab here, if we click on this drop down menu, you are going to be seeing columns, your beam, your truss, your pole line, your guards, your brace, your frame, your cladding, and your steel dome. So we are going to be using all of this in our models. Okay, so the first thing you need to do when you want to come up with your steel model in ProtaSteel structure, you will have to actually insert a grid. So it's either you are importing or you are actually doing the entire grid alignment here in the ProtaSteel structure. Okay, so if you are either ways, but like you know, when it comes to steel, the plan is always very straightforward. It's not as complicated as that of the reinforced concrete designs. So I'm going to use a space of let's say I have 2 meter. So in order for you to offset this, if I click here, I will have to right click. If I click on offset, I will have to hold on F2 and then I will type in the value. Now because I am moving in this direction, there is always an invisible plus, they tell you in mathematics. So it's going a positive direction. I don't have to add the plus there. But if I am going in this other direction, for example, if I want to go the opposite direction, like backward, let's say I want to go this way, I will type F2. I will have to type in the minus before type in the value, typing in the distance. Okay, so you can see it has gone backward, but I don't have need for this. I'm going to actually delete it. So I will create another grid here, and then then I will offset this to, let's say, upward, which is up to 6 meters. I can have another and then have another 6 meters. Alright, but like you know, when you are trying to do your steel design, you must have a reinforced concrete footing. Okay, so that reinforced concrete footing is what we are actually going to provide here now. So let's assume a footing of 400 by 400. So mind you, the steel section you are actually making provision for will determine the size of the footing you are actually providing. Okay, so before that, I will have to insert the number of stories. Okay, so to insert my story, all I need to do is to right click on this story and I will click on insert story. So I can specify the number of story. The reinforced concrete footing is going to be a story on its own. Then the steel column, the entire overall height of that column is going to be another story on its own. Okay, so that's we having 2 stories already. Okay, so for now we are going to type in 2 as the number of the stories. If there is need for us to create another story, we are definitely going to do that as we proceed in the modeling. Okay, so I just want to let you know that modeling in ProtaStructure is very flexible. The basic things you need to understand is how to use the tools in the ProtaStructure to achieve your modeling. So whichever way you use to achieve your modeling, the main thing is to get that modeling done. Once your model is done, the software can analyze it and design it for you. Okay, so you may most likely not use exactly the same approach to achieve your modeling. Okay, but the goal should be getting that result, and that result is achieving the specific modeling you want to achieve. Okay, so if I type in 2 as the number of my stories and then I will click yes, you can see it says this and the previous processes will not be undone after this step. So I will click on yes. So all I need to do is to come back to this story and right click on it, and I will come to edit story. So when I come to edit story, I will type in this as 600. Okay, so this story is reinforced, this one is steel. Okay, this is 6 meters height. So for now, like I said, I'm going to leave it as it is. Then you can specify the depth of your foundation. Yeah, so I will click on OK. So I have insert my stories, and you can see this is showing me here at the top here that this is story 2 plan. If I alright, so after inserting this, I always like to have two views, one in 3D view, the other one in 2D view. So I will right click on this view and I will click on 3D physical modeling. So this is our 2D, this is our 3D, and I will come to view here and I will click on tile vertical. So I have my 2D here, I have my 3D in this area. Now the next thing I'm going to do is to switch to my story 1. So I'll first of all click on this window and I'll double click on my story 1 here. So I will come to my modeling and I will click on column, and I will insert the thickness of this footing as 400 by 400 for example. Mind you, your design, when you are designing, it should be safe and also economical. Okay, so we are going to insert all the necessary reinforced concrete column that will be here carrying the steel stanchions. Okay, so we now have our column here. The next thing we need to do is to insert a steel column as well. Mind you, I am not going to specifically select a particular steel section. I'm going to leave this at default. Then by the time we analyze this structure and design the structure, we will be using the utilization ratio and the slenderness ratio to actually play around with the steel member until we get that particular steel section that is going to be safe and economical as well. Okay, so it's not just the safety but the economical, how cheap that steel member can be because of your client, after considering all of the kind of load that will be acting on that steel member. Okay, so like I said, I am just going to pick any steel cross section. So this is the cross section that we have there by default. So even if I click, I can simply just change. So I'm going to leave it at 305, 305, 97. So like I said, later on the design will tell us if we have a need to change that steel cross section, or either to reduce it or to increase the steel cross section. But if you are very familiar with your steel designs, you will most likely already have an idea of a steel cross section that will serve on the project that you probably want to consider. Whether you are designing a warehouse, you already know, probably based on the span of that warehouse, that will most likely the span has so much effect when it comes to the loading of the steel, whether it's a truss or a steel beam or a steel column. Okay, so you already know some of these steel cross sections already that will serve, so it spares you a lot of time, the time in which you will start going through changing your steel when it comes to checking for the utilization ratio and the slenderness ratio and all of that. Okay, so experience already helps you to spare a whole lot of time. Okay, so now I'm going to just insert all of these steel cross sections, all of these steel members where they are supposed to be. Okay, sorry, I am making a very big mistake. It's not even inserting, I think. Oh, sorry, I am in a very wrong story. Oh my god, I'm in a wrong story. So that is why it's not even reflecting in the first place. Okay, so it's a good thing that it did not even reflect. You know, this steel is actually 6 meters, while this reinforced concrete is just 600 mm. So this particular story 1 cannot even accommodate it. So I will switch to story 2 because this is where I am supposed to insert that steel column. So if I click on this steel, I will place them where they are supposed to be. I can simply highlight as well and it will be inserted. So you can see my steel column here has been inserted. Let's say I have a steel beam that goes across this and this. You can change your steel cross section for your beam as well if you already have an idea of the steel member or steel section that will serve. So but if you don't, you can as well follow this pattern, and then while the analysis is completed, and from there you can simply just actually know if that steel member is economical or is too high. Then you can change the steel cross sections. You can either increase or reduce them by the results the software is generating for you. So if all of this is done, now I can just insert a steel truss. Let's say I want to insert a steel truss here. I will click on steel truss. I will click here. Okay, I think it's loading in the background. All right, perfect. Now by default the software itself has different patterns of your steel that you can actually just adopt from here. Like, you know, most of the steel trusses that you find, most of them are will most likely fall around these patterns that are here. So but then even at that, there are some steel patterns that may be a bit more complex than this, that is not going to be very easy for you to achieve the model directly from ProtaSteel. So you can simply import from DXF, which I'm going to be showing you that in the next episode. So I'm going to be showing you how to import a steel truss. Okay, so probably the architect has already given you a steel the cross section of the warehouse or a church or whatever you are designing for. From that cross section that is given to you by the architect, you can just simply just use it as it is. Okay, all you need to do is just to import that cross section into your ProtaSteel and use, because it may not probably be easy for you to actually do the modeling directly from ProtaStructure. So if that is correct, you can simply just pick the cross section you want to adopt. You can see by picking this, it's giving me different patterns. So these are the truss types, and then each of these truss type has different patterns. Okay, so and each of these pattern you can as well even edit them. Okay, so if I click, you can see it's bringing me here. From this point here, I can re-edit this particular truss member. You can see it's telling us the top chord here, which is this. This is the vertical chord, which is this. This is the diagonal chord, which is this, which is, then we have the general. I'm going to be showing you this once we import. It is going to make a whole lot of sense to you more when we import a steel member. Okay, so we will be editing. You can, as you can see, you can select any of the member and delete them, because sometimes probably for the sake of saving cost, you may want to. I have seen designs where the vertical chord is being knocked out, okay, and like that. So I'm going to click on cancel. Sorry, I'll come back to this. Click sorry, steel truss. Click here and click. So you have to click on 2 points. So let's say I want to adopt this. All I need to do is to, here now, the apex height, as you can see, it's always user is user friendly, and it is always guiding you on whatever step you actually want to take. So as you can see here, this is telling us this is HA. If you trace here, you are going to see all of these are labeled. You can zoom however you want it. So you can see this is HA, this is L, which is the length. Okay, so I would like to say this is looking very, very, very small, so I may probably need to increase the width of this. So you can play around with it. It's a good thing that we made this mistake from the beginning. It will help you to understand how to actually readjust to whatever you want to. Okay, so let's say I want to probably increase these. I can just offset, and let me make this like 1000 more. Okay, or I can even just make it 4 meters. Offset F2, and I'll make it 4 meters. Okay, so I'm simply just going to I can just simply move, or I'm going to just highlight these members and delete them. Okay, I can just delete them, and I click OK. I'll highlight these and delete. I can select, click, hold on Control to select all of this and delete. Okay, so all I need to do is to go back to my story 1. I will click on this window first, then double click on story 1. I will have to delete this concrete column as well. I'll click on column 400 by 400. So I'll place them here. I can take out this by clicking, right click on delete. Okay, so now I will switch back to my story 2. I will double click on story 2 and I'll come to this drop down, click on steel, and I will insert. So from experience, I know that most times the steel members that are in the center here will definitely carry a higher load than these ones here. Okay, these are biaxially loaded, these ones at the extreme ends. Okay, so these columns that are in the middle are carrying a higher load, so the cross section for these columns, the steel members here, should most likely be, or definitely be, higher than the cross section here. But sometimes we adopt the same for all of them, probably because maybe during the fabrication some of these people on site may not want to adopt different cross sections. Okay, but for the sake of cutting cost, these cross sections should most likely be smaller, because it's not going to be carrying as much load as the ones here in the middle. So but I'm just going to adopt everything as the same. By the time we analyze this member design, you are going to see how we will play around with it proper. So we have this now. I'm going to come back to my truss and I'll click on truss. I will click on this and I'll click on this. Okay, so I will click on this member. You can see it's looking a bit bigger, it's making more sense now. The other one looks very shrink. The height here, you can play around with this height. You can either reduce the height or you can increase the height, so pending the cross section that was given to you, okay, by the architect. So the cross section that was given to you by the architect will determine whatever you are doing. So mind you, you are just reproducing the cross section of the architect in terms of the height, in terms of the width. It is your responsibility as the engineer to specify the cross section of each of these members. Okay, so the architectural cross section is different from the cross section of the engineer. So you as the engineer, you determine each of these structural members that can be able to withstand the load that is going to be acting on this structural member. Okay, so the height, let's say, was given to us as 2200. The moment I type in 2200 and I type enter, you will discover here this in real time is going to readjust. So you can see this has readjusted in real time. So the number of spans, you can see, if you count, this is 6 here. If you count 1 2 3 4 5 6, so it's going to be 6. If you try to reduce, it will reduce. If I make this 5 span, for example, and I click enter, you discover the number of spans will reduce. If I increase it to 6, it increases. I can introduce a cantilever to the left. Let's say that cantilever is 600, and then I introduce another cantilever to the right. Let's say that cantilever is 600. You can see it's taking effect automatically as I'm imputing all of these values. So you can simply take your time to readjust all of this. You can offset left, offset right, and all of that. So if I offset left, let's say by 600, you are going to see how it's going to take effect here. You can see it is showing us 600 here. I bet this is not what I want. I'll change that to 0. So similarly, you can do that for the right hand side. Okay, so that being said, now if we are satisfied with all that we have here, all I need to do is to click on OK, and if I come here, I can insert them in each of these points. Alright, the next thing here I need to do is to insert a polyline for this. So if I click on polyline, now this polyline, I can either take it at each span, or I can take it from here to here. So if I click on polyline, now you can see the polyline menu will pop up here. Similarly, just like I did for my steel beam, steel columns, I can actually pick a polyline cross section here, or I can actually just leave it as it is. By the time I analyze this building, this structural members entirely, and by the time I analyze it and design it, I will be able to know if the cross section is economical enough, or is actually very too high. So in that case, I will be able to reduce or increase. Okay, so if I click on OK, here I can as well play around with the polyline. You can see polyline here has a sag rod. I can either take off that sag rod, or I can leave. If I come to the sag rod here, I can, if I make it none, you can see all of the sag rod has been taken off. Okay, so I'm going to leave it at automatic. Include the analysis, I will leave it checked. Offset from first edge, you can go as far as introducing. You can see the offset of 200. I can reduce that offset, or I can increase the offset. Let's say I make it 300. You can see in real time, first edge, first axis, last edge, last axis, whichever way. If I type in all of these values, it tends to change its positions. Okay, but I'm just going to leave them exactly as it is, so I'm not offsetting it. So you can increase the offset, you can reduce the offset. You can see like I said earlier on, it's always gives you a guide, like a preview of what you have here. You can see this is telling you that this is your E1, your E2. Okay, it tells you all of that story here in the preview. Okay, so you have a better insight of what you are actually controlling from here. Then the steel material, that's the steel grade, you can as well change to whatever steel grade you are actually going to be using. Alright, so if I click on OK, that has been generated for me now. So let's say I want to have like a beam. I want to have like a beam. Sorry, this cantilever is going to be a serious obstruction for me. So I will have to remove this pole line and delete all of these trusses. Or let me come to the property of this truss. Let me just remove this cantilever. I'm going to remove the cantilever and I will click on OK. So I have removed the cantilever. I don't want that cantilever, so I will use the pole line. So like I said, it's actually modeling. It's modeling. This is you modeling, trying to get the exact shape of what you want. Okay, so I'm just modeling this right now, just trying to model it to whatever I want. Let's say I now am going to have a cantilever here, have another cantilever here, so it's going to be a beam. I will introduce a steel beam, but before that I will have to create a new axis by this side, create another axis by this side as well. So let's say I want this cantilever to be 3 meters. Okay, I will type 3 meters. So I will also offset this cantilever F2 at 3 meters. Oh, sorry, mind you, since I'm going this way, it has to be a negative distance, so minus 3 meters. F2 minus 3 meters. Enter. So now I have this. So so I will introduce the beam, the first beam here. This is what I have. Oh, sorry, this is reinforced concrete beam. I want a steel beam. I'll click on beam, I'll click here, and I click here. So if you look at this from the 3D, this is exactly what I have. So I am going to make this at the I. You can see I have I here, I have J. So at this I here is already a cantilever, but I want it to slant to a height of 1.5 meter. So if I click on this, I'll right click, I'll come to the property, I'll come to the 3D. You can see this is showing J, so this is J, which was what we have here. So here I'm going to make it 1500. So once I click, or play, okay, sorry, I forgot. The reason why this is not working is because I will have to introduce another story above. So in order for me to slant this to that story, I will insert a story and you can see a story number greater than the top story will add story above. So you know, I have story 1, I have story 2, so I have to type in story 3. So this is going to be our story 3, and the height of this story, I want it to be 1500, and I will click on OK. So this member, I will right click on it and I will go to the property. I will come to the 3D here and I will type in 1500 and I will update. So similarly, I'm going to do for every other beam along this. So once I do that, it's going to, I think it should adopt exactly. It will adopt it. It will adopt it. So I don't know, although the cantilever looks very small, so I'm going to just undo all of this. I'll delete this. I will offset this and make it let's say I make this 4500. So I will delete. I'm going to make this 1.5. So I'm going to definitely change the cross section of this steel member. So, oh no, steel. Updates. All right, good. So let me do for so you can do that similarly for all of them. I will offset up to minus 4500 and I'll press enter. Now good, it's a good thing that this happens here. In this case, I will have to stretch this axis. I will right click on it and click on stretch. So I'll pick these points to stretch. I can stretch all of them similarly. So in steel design, the major aspect or the major work you do is just the modeling. So that is the major work there. The major work is the modeling. Once you are able to get your modeling right, the software will analyze it for you and design it for you. As simple as that. So if I come to my steel beam here, I'm also going to insert this beam. Alright, good. Let's leave it like this. Deliberately, I'm going to show you how to reverse this. So in order for us to reverse this, I can just highlight all these beams by holding on my control to select all of them to pick. If I come to the property here, you can see it brings out a menu for us. Now, you know, this is I, this is J. So along DZ left, which is this, I can just use this that looks like a pen. I'll take that again. I'll click here to highlight everything. Click this that looks like a pen, and I will make this 1500, and I will click on OK, and DZ right, I will highlight, click this that looks like a pen, and I will type 0, and I'll click OK. Now that has been done, so we can see it is now back to what we want. So I will come to my polyline here, and I will click, and I will click. Okay, I take that again, click on polyline, click here, click, and click OK. Let's see we are satisfied with what we have. Now I'm able to model this. So however you want to actually do your modeling, even if you want to even have another like a cantilever below this, all you need to do is to introduce an intermediate story, okay, that is a bit below this, and just take this all over again. It's the same process, the same tool, the same pattern. Okay, so once you are able to model this, now the next thing is to insert a gap now for this connection, for this our steel stanchions. Okay, so the guards, it's more like your polyline. All you need to do is just to as well insert the information. So you can see the spacing here is 1 meter. You can reduce the spacing to however you want, whether it is 900. You can see it's reducing. You can take it back to default if you like. You can as well, the bottom offset, from the bottom offset is 200. From here to here, you can reduce that. You can see it is always interactive. It tells us whatever we are typing here tells us, and it reflects here in real life, okay, in real time. Okay, so you can as well knock off or take off that sag rod, because this is a gap. You can take it off if you like. So that being done, you can just click on OK. So similarly you do for this, and click this, it gives you the same thing. So but if you look at this, you will see that this has been provided at inside instead of outside this, and I think I made a mistake. I didn't capture the entire columns, but I'm going to quickly demonstrate this by double clicking here. Okay, if I double click here and I click on under section, it's going to take this out for us, but mind you, I'm going to even delete it. I don't need I'm going to take that all over again. So I'll come to my guards here, I'll click here, and I click here. Okay, that didn't work. Pick it, click, and I'll click OK. So like I said, however I want, I can as well even brace these if I like. So let's say I want to brace these. All I need to do is just to come down here, click on brace, select the member I want to brace, and I will click on OK. Select this to brace, and I click on OK. So I can just brace 2 at a time. I can as well brace this So if you are able to model to this point, I tell you a very big congratulations, because this is most likely what you are going to be repeating in most of the modeling you are definitely going to be doing. So you see the process is always similar. There is no much difference in the modeling in most of the processes that you are going to be, whatever you are going to be modeling. Okay, you'll discover the difference are actually not going to be that much, won't really vary much. Okay, so we have come to the end of this episode. In the next episode, I'm going to be showing you how to model by importing a steel cross section. So we are going to import a steel cross section, then we do the entire model, then we will do all the entire modeling that we actually want to do first. By the time we are done with all the models, then we will now go into designing proper. So there we'll be able to play around, changing our steel cross sections and all. So I will see you in the next episode.